What's up, everybody? So, looking at today's video, we're talking about those systems of inequalities again. Here's your learning objective. I can graph systems of inequalities. And we're looking at basically what it means to be that system of inequalities. Here's the graphing method. Here's an example that we could just see what really happens with this stuff here. Let's say we had that x plus y is less than or equal to 6, and that 2x minus y is greater than 4. We're going to graph them separately and then put them together on the same coordinate plane, and you'll see what happens to it. X plus y is less than or equal to 6. That's standard form, and I can find the x and y intercepts by just plugging a 0 in for the opposite. I'll see that it hits at 0, 6 and 6, 0. Or I could take that x, move it to the other side, which means I have y less than or equal to negative x plus 6. Where I have my plus 6 right around here. And then the negative slope means the negative 1 slope, so I'm working my way all the way down. There's my 6 intercept. So there's my inequality. Solid line, less than or equal to, so we're shading everything below. There's my inequality. Let's do the same thing for the second one here. The second one, we had 2x minus y is greater than 4. Plugging in zeros, I get negative 4 for my y-intercept, and I get positive 2 for my x. If I solve this for y, I would have to move the 2x to the other side and then divide by a negative 1. Dividing by a negative 1 means I get negative 4 for my intercept and then a positive 2 slope. This should be a dotted line, and then dividing by that negative means I change the inequality symbol around. It would be shading underneath because it would change to less than. So now we've seen the two graphs separate. If you're thinking of a system, you put them together. You put them on the same graph simultaneously. Take a look at what happens. This is with both of them on the same coordinate plane. The green from our first inequality, the red from our second inequality, and it creates this weird looking brown color in between. I like making it brown because most people remember this one because of how ugly that brown turned out. But the solutions to our systems was where the two graphs intersected. Well, now it's the same kind of thing with inequalities, except you have more than just one point. It's not just that intersection point. It's where the shades intersect. So any point inside this brown region, inside this area where they share solutions, those are solutions to the system. Here's what we did. Here are the steps. Step number 1, write the inequalities in slope-intercept form. Step number 2, use the slope and y-intercepts to graph those lines. Step number 3, draw in the lines, remembering that it's solid for less than or equal to or greater than or equal to, but then dashed for less than or greater than. Then we looked for the shading. If it was greater than or equal to, we shaded above. If it's less than or equal to, we shaded below. The last step, guys, we found where those two shades intersected, and we made sure that was a little bit darker for that shade. Let's take a look at some examples. Here's example number 1. Going through our steps. Step number 1, get them in slope-intercept form. Oh, already there. How do I know that? Because the y is all alone in the first inequality, y is all alone in the second inequality. Now I could graph using my slope and my y-intercept. 2x minus 4, I know that minus 4 is my y-intercept. That 2 is my slope. So I could start at minus 4 and then go up 2 over 1, up 2 over 1, up 2 over 1. Then I could use my line. For this one, it's greater than or equal to, which tells me solid line. Last thing I need for that first inequality is the shade. I know that it's greater than or equal to, so that tells me I'm shading below. Oh, sorry. Greater than or equal to, that means I'm shading above. There's our first inequality. shaded and graphed onto our coordinate plane. With the same one, let's graph the second inequality. I have negative 3x plus 2. Plus 2 is my y-intercept, so I put a point down at plus 2. Negative 3 is my slope, so I go down 3 over 1. Down 3 over 1. And I keep going until I get enough for my line. Looking at the line we have to draw here, this is just less than. So I need to draw this as a dotted or a dashed line. And then the last thing, I need to look at my symbol. This is less than. So that tells me to shade everything below. Can you guys see that? Here's our first shade. We have line and everything set up for the second inequality. Look at where that second inequality comes in. This is what I really like about this PowerPoint. It's a little bit transparent of the shading. So you could see where those shades truly overlap. You had that slight greenish shade for the first one. Now you had that purplish, bluish shade for the second one. And you could see exactly where that shade overlaps. So our solution for this one is only where both shades overlap. So it's this entire red region right there. And again, you could see that from what overlaps in the shade on the two inequalities. Let's do another one. Our last example for this video, we've got y greater than negative x plus 4. We have y greater than x minus 2. First step, get them in slope-intercept form. They're already there. Y's are alone. Second step, graph them using our slopes and y-intercepts. My first inequality, my y-intercept is the constant plus 4. And then it has my slope negative 1. So I'm going to go plus 4 for the y-intercept. Negative 1 tells me down 1 and over 1. Looking at this symbol, it's just greater than, not greater than or equal to. So I know I'm going to use a dotted or a dashed line. And then I need the shade. We're talking greater than here. Because of that greater than, I want to shade everything above. Last, I need to get the second inequality graphed on the same coordinate plane. It's y greater than x minus 2, minus 2, y-intercept. Positive x, that's a positive 1 for my slope, so that's up 1 over 1. Drawing the line for it, it's just greater than again, so that means I'm going to have a dotted line, dashed line. And then I'm shading everything above because I'm greater than, so everything above. Take a look at where this shade overlaps. This one's a little easier to tell. There's our shade from the first one. There's our shade for the second one, and you could see where they overlap. That shaded region is our solution. One more time, just for the shade, because I really like this, to be honest. We're shading above that green one. Now we have our second line. We're shading above that one. We could see overlap in that top corner. That's my solution. Alrighty, guys. Email me if you got any questions about it, or just show up in tutoring or async, and we can talk this stuff up. We'll see you guys.